So here we're going to talk to you about the veraPDF project, which started in October of 2014. And these slides will give you a little bit of background into this project. And a large portion of this discussion will be, for those of you who are not familiar with veraPDF so far, we're going to tell you a bit about the project, the nature of the software, the nature of the implementation. We're also going to give you an update on the status of the project and tell you where it's at very specifically and where it's going to be going from here. Before I start, I'll mention that one of the ironies to me in the veraPDF project is that it's very much in line with the original conception or some of the original purpose behind the PDFA Competence Center and then, of course, later the PDF Association. As I understand the origins of the PDFA Competence Center, it arose out of the need that a number of vendors had who discovered that when they went to develop PDFA implementations, they would not always find that they would agree. That is to say that the specification was sufficiently vague and included sufficient requirements that pertain to other specifications, PDF, fonts, and so on, that generated a number of ambiguities. So the PDFA Competence Center was initiated in no small part to give these vendors a place in which they could meet and collaboratively develop a consistent understanding of what PDFA meant. So from that, and I take that very much as a sort of the basic fundamental inspiration that has resulted in today what we would call the veraPDF project. So this talk about veraPDF and building, and I think we'll find certainly perhaps less so in this session, but perhaps in others, the term definitive is a rather controversial one in this context. And I want to mention at this juncture that definitive is not a term that we chose. We may be happy with it, we may not be happy with it, but it's a term chosen by the funder of the project, which is the European Union's PREFORMA project. So Boris and I are here to talk to you all about veraPDF. First of all, why PDFA? Many of you know the answer to this question, but I think it's important to iterate it very briefly. Users need long-term preservation of their electronic documents. They come to PDF for this because there's fundamentally no other option in the document world. There are images that people use for this purpose or have used prior to PDFA, but as we learned earlier in the PDF raster session, TIFF is something that's never made archivists or indeed software developers happy from the point of view of longevity. And PDFA is in no small part a response to that. So documents are becoming, TIFF also was there because fundamentally archival documents had become printed at some point. Then when they were imaged, they became a TIFF, and this was the basis for why they would be archived in a TIFF format. However, in the modern world, documents are becoming final without ever seeing a printer, as it should be. And so then the TIFF format, an image format, is basically not a great idea in that particular kind of context. So PDF, it's a document format. It's not an image. And so PDF is superior to TIFF in that regard. And while it accommodates raster image data just as TIFF does. So PDFA, as you know, restricts the use of PDF to that certain subset of features and requires that aspects of PDF be in place, such as embedded fonts and so on, that ensure that the PDF file is going to reproduce accurately, irrespective of the system on which it's used. So PDFA, in broad strokes, is a platform for the creation and retention and processing in a reliable fashion of these electronic documents. So if it's all about archiving, why would PDFA, this in a sense tells us right up front why validating PDFA matters. Users want to know, will their documents be good in 5, 10 years, 20 years, 100 years? We, in fact, regularly encounter users who come to, in fact, to the ISO meetings who have document retention schedules that are 100 years or longer. Some in the government agencies require schedules that are indefinite. They have no fundamental limit to the extent to which they might want to retain their files. This isn't just about long-term document retention, however. If a file is not correctly built, it might not appear the same way on a system right across in the other building, quite apart from being over a time period of years, all depending upon the nature and the way in which it was created. So the nuclear industry, aerospace, engineering, financial services, the legal world, these organizations demand a very high degree of reliability in the documents that they consider to be vital to their own business processes. And they ask the very reasonable question, and I see that, you know, when Olaf asked at the beginning, how many have seen PDFA files that, in fact, well, a file claiming PDFA for which different software disagreed on that subject, most of you raised your hands. This is not a good situation for a format that we're attempting to call that we're trying to declare as an archival format. If your software and my software disagree on whether or not this is PDFA, we both have a problem. So the PDFA flag, as we know, doesn't actually say anything all by itself. It's a claim. You could add a PDFA flag to any document, and it doesn't offer any real definitive statement about whether that document is valid or not. We have to go beyond it, and so we then arrive at the subject of PDFA validation. And PDF itself is a complex subject. So why the veraPDF project? PDF, as I mentioned, is complex, and there are many specifications referred to by PDFA and PDF specifications. Do these things does everybody understand these specifications the same way? No, they do not, and the meaning of these documents themselves is not always very clear just at the outset. There's not an enormous amount of revenue to be found in validation. What we found over the 20-some years of PDF being in existence is that much of the money in PDF is generated in the creation of files, not so much in the processing of the files. So there's a lot of there's a need to drive there's a need, if we have validation, there may be a need to drive development of validation in means other than strictly based upon or means that aren't necessarily rooted in a commercial origin. So the industry, as it's understandable, the industry is limited to the extent that valid files would be something that you'd require commercial software in order to use. The whole premise of PDF is that it's an open format, and if we're required to use something commercial in order to determine if it's valid, that's a significant constraint on the idea of an open format in the first instance. So what would a validator, if we had a definitive validator for PDFA, and indeed for PDF itself, what would we get out of that? We would really be achieving the ultimate objective of PDF, which is a document format that's fully interoperable, where the format, the platform, software being used to process it is immaterial. Everybody gets the same results all the time. So the target audience for the veraPDF project, fundamentally, and this is a result of the influence of the funder, who was originally inspired by the needs of libraries and archives, both of the academic and governmental type. Developers leveraging ISO standards for PDF, we had those in mind in creating the veraPDF project because we knew that we'd be encountering all the various kinds of ambiguities that are present in the PDFA specification. And in fact, the PREFORMA, the funder, wanted the project to be able to discuss these ambiguities with the standards development people, and thus influence the specification directly. And this has actually been the process as we've moved along with it. So we obviously want to influence PDF software developers. We ideally very much like for veraPDF to help set the stage for all and assist PDF software developers in coming up with a consistent implementation and understanding of PDFA. In the enterprise content management and customer communication spaces, the people making products in these spaces are also looking for consistency, and they wish to be able to represent to their users that the files that are generated or maintained or contained within their systems do in fact have long lifespan, and that they needn't concern themselves with migrating between formats. That they can keep their migration concerns down to the hardware or other kinds of indexing or subsystems that they use to manage and maintain this content. So the government is particularly interested in validation because the government is interested in open source technologies in general, and ensuring that that it's using open technology and that it has the ability to validate this without reference to a particular vendor's implementation is something that the government has come to understand is of significant value to them as well. So for business, in developing veraPDF, we have to come up with reasons why people are going to be particularly interested in it. For PDF technology developers, the theory is that if there's a solid and broad-based understanding of what valid PDFA means, then there's an opportunity to reduce software development costs. There's an opportunity to manage support costs. If it's possible to say that this file is definitively valid or definitively invalid, then that implies that various people may be responsible for that file, maybe perhaps not the person processing it who identifies the problem. Technology developers want a means of assessing for quality the various PDF technologies that they acquire and implement, and they are obviously they're looking for improvements in terms of reliability and performance across their various solutions that they deliver. And customers, of course, are very interested. They want to know, boy, somebody gave me a file and it claims to be PDFA. Is it? Is this something I can rely upon? Can I stick this in the archive and be sure that it'll work for a long time thereafter? So what is the veraPDF Consortium? It's an organization brought together for the purposes of creating this software. It's led fundamentally by digital preservationists. That is to say, the archivist community is a world of the libraries and academic, government, and indeed also corporate libraries that need these sorts of technologies. And our partner in this regard is the Open Preservation Foundation, which is a British-based organization, a consortium fundamentally of libraries and archives that take the lead from that particular point of view. The PDF Association brings PDF expertise and the connection with the standardization organizations. Digital Preservation Coalition is likewise another organization of archivists. So in the PDF technology industry, the PDF Association provides the PDF background for the development of this document, for the development of this software, and for the test suite. And Dual Lab is contracted by the consortium in order to provide the software for this purpose. So PREFORMA, the customer, just a word about them. This is a pre-commercial procurement project of the European Commission. And its purpose is essentially to generate resources to seed the development of software that the EU decides is in the general interests of its membership. They want to give memory institutions control over understanding what it is that they ingest, so they can have a better, wow, it's warm in here, better use of this stuff into the future. And the PREFORMA project is funding three different kinds of validation of three different kinds of formats: PDFA for documents, TIFF for images, and two different video formats for archival purposes. So I'm going to turn it over to Boris right now, who will tell you a little bit, begin to tell you more about the situation with respect to the test corpora that we started off with, the test files that we've been developing, and the software itself.
Yeah, as mentioned before, we handed a task to develop an open source validator, and most, if not all, code has to be developed from scratch. That's a huge task, and well, initial estimates were at least several man years, if not more. However, we could rely on the assistance from PDF Association in the form of a technical work group, veraPDF work group, and excellent advices from vendors who already went through this path and implemented similar validators before. So a way to start, well, that's not fully correct. So test corpora is a way to start developing the validator, but of course, a way to start is to start reading PDF specification and the specifications of PDFA standards. So this all starts with this. Then we had to set up what archivists call ground truths, something which we could use to discuss whether what exactly this or that clause from PDF specification means. And one of the ways to discuss is to discuss this theoretically. Another one is to discuss this practically, meaning generate test file and ask a question whether you think this is a valid or invalid test file according to all specifications we've got in our hands. And we also had an excellent example of such activity in the form of a Sartre test suite generated some time ago, I think back to 2008 or 9, for PDFA part 1. So there were several additional test suites known as Bavaria or PE4 covering PDFA-2. Altogether, they had 323 atomic self-documented test files. Atomic means they always deal with just a single clause from one of the specifications. Self-documented means you open the file and see in bookmarks what exactly this test file means. So you don't need to go deeper into low-level PDF debugging inspection tools to understand what it is all about. Our initial estimate was that we need at least 500 new test files for full coverage of all PDFA parts and levels. And as usual, we proved to be on the lower end of this. And just to compare, well, you know that XML1 is just basic XML, no schemas, nothing, just XML itself is a fairly simple standard, documented in 38 pages. Still, when you go to w3.org website, you see over 600 test files from several different vendors. So this, you see change of color a little bit on the background of the slide. You'll see them from time to time. This is the report where we are right now. So at the moment, we've got so many test files, so 179 new test files in addition to Sartre, 223 test files in addition to PFO. Then we have 3 extra test files on embedded files for level to cover part 3. A few level A test files, a few level U test files. There are not many, and these numbers will probably grow within the next half a year. But in general, there are also quite not so many requirements on levels U and A in PDFA standards. We also spent some time to go through XMP specifications because we've seen quite a number of questions and ambiguities related to XMP specification itself. So here I'm proud to say that we've got what we would call full coverage for both what's specified in PDF-A and what is defined as so-called predefined schemas in XMP specifications themselves, and there are 2 kinds of XMP specifications used in PDF-A. One is used for PDF-A Part 1, going back to 2004, and PDF-A Parts 2 and 3 use a slightly updated version from 2005. So how these test files are created and how do we make sure that these files are good? So first of all, as I mentioned, we go starting from the specification. So this is a very typical clause, and this is a shell clause because we cover only shell clauses, so hexadecimal string shell contain an even number of non-white space characters, each in the range of 0 to 9, A to F, and A to F small case. You see even here how actually difficult it is to understand just this simple clause. In particular, it refers further on to what is a white space character, and for this you have to go to a different section. And lucky enough, we have an exact definition of what is a white space. And one of the questions in particular discussed was whether a null character is allowed inside hexadecimal strings and whether it would be considered as a white space character or not. So we see that what happens then, for each such clause we generate a number of test cases and test files. So in this particular case we ended up with 2 fail files and 1 pass file. What's important is that we generate not only fail files as in case of a Sartre test suite, but also pass files. About 1/3 of our test files is actually pass files. And this is also very important to avoid fail alarms during the development. Because, well, missing an error is bad, but learning things which are actually good is about that bad. So test files are created, and as we are developing an open source tool, everything is placed on GitHub. This is a source repository for everything, source code and test files. We go through internal validation, as well as we pass all files which seem to be controversial or which cause some ambiguities to the PDF validation technical workgroup for further discussion. And actually what's going on, each such test file is passed through a representative set of existing validators, because one of our major goals is to find, to achieve the consistency between the existing validators in particular. So as soon as we see that any of our test files generates mixed results, meaning one of the tools says it's fail, another one says it's pass, we immediately assign such test files to the PDF validation technical workgroup mailing list and start from the discussions thereon. Well, as soon as the files pass this discussion, and during this discussion we might change our resolution for test files, and sometimes we have to return to these questions later, like in several months due to new evidence discovered. Then we announce, we are going to announce this corpus as a release candidate, and hope for looking forward for formal acceptance by PDF validation technical workgroup. So the next milestone is actually July 15, where we have to deliver the release candidate of the complete PDFA corpus. At the moment, we've delivered so far PDFA level 1B corpus, and we're looking for feedback. Well, in more detail, how does it go in practice? So you've seen that we generated over 1,000 new test files, and like most of them, overwhelming majority is consistent across different validators. This means the situation is not that bad. So in most of the cases, existing validators do agree with each other. We have got about 50 test files where we get different validation results due to different understanding of implementation limits, how unused resources have to be treated, metadata compression, and 20 other ambiguities. We still have about 12 test files which are marked as undefined in our repository, which means we still don't know whether these are valid or invalid test files. We might have our own opinion, but we still haven't got sufficient feedback or evidence to make a decision. Some of them are related to validation of XMP metadata or consistency of PDF info dictionary and XMP metadata. Some of them rely to quite, well, maybe a bit theoretical cases when default color spaces on the page should be applied for tiling patterns and type 3 fonts, and then color operators which are not allowed but can be used in uncolored tiling patterns and type 3 fonts. These are kinds of low-level technical questions which are still in discussion. So what exactly we are trying to validate outside or within PDFA validation, because PDFA itself refers to many other standards, and we had to decide where to draw the edge between PDFA itself and all other specifications it refers to. So the decision was taken that we do validate only the clauses which are explicitly stated in PDFA specifications themselves. In particular, this means that we are not doing validation of embedded fonts, internals of embedded fonts, which are not required by PDFA itself. But PDFA itself does include a number of clauses related to encodings, existence of glyphs, and so on, or with consistency of bits. Other than that, we don't go inside font outlines, for example. We don't check if outlines are okay, if the contours are oriented correctly, and so on. The same for ICC profiles. We do check the version of ICC profile because this is one of the requirements, but we don't go further inside to check if the curves are correct and so on. XMP metadata, here we went quite deep into actually checking what's inside XMP metadata, but are not actually, we don't derive any fail or pass results based on some very specific conditions inside predefined schemas. We just check again what's stated in PDFA standards. Now, image compression and well, digital signatures are probably to mention here as well. So instead of going inside this embedded data during validation process, we provide a so-called plugin mechanism that would allow any third-party tools to add or contribute to checking this embedded data. Again, whatever these tools would report to us will not alter their validation, PDFA validation result itself, but might be handy in case some institutions have more specific requirements. So some institutions might want to have extra checks for embedded fonts. So it's, I'll cover this a little bit later. And in general, we are trying to set up a certain collaboration scheme with experts and relevant technologies, in particular font technologies, image compression technologies, because we are not sure that we possess all necessary knowledge here to go deep into these embedded formats. So how does it work in case of plugins? So what we do, we take out of PDF all data, we uncompress everything except for images, because compression of images is already a part of their internal structure, and pass this to external plugins, which actually do not need to know anything about PDF syntax itself. All they need is just to handle this particular embedded file format they claim to know about. What they say to us is added to a special part of our report, which is called feature report. These are all features we or some other tools may discover in PDF documents. So features is something aimed for further policy conditions specific to the institutions. This is not a part of what we report as a validation report. So as it looks now, and these are samples of plugins we developed during the collaboration of other third parties. So for GPLv3 2000, for example, we have integrated an excellent GPLizer Python script that already implements the validation of GPLv3 2000 itself. For other image formats, there is nothing else done, and we are really looking for contributors, for those who has in possession the code that validates this and who is willing to share this code and convert it to open source. For TrueType, CFF, and OpenType fonts, there are two tools available, open source, freely available, let's put it like that. One of them is from Microsoft, but it's not suitable for any kind of integration into workflows, because this is a desktop tool on Windows. There is another open source tool coming from Chromium and Firefox called OTS Font Sanitizer, and we've been doing integration of this tool. It does really check all low-level requirements of, for example, OpenType and CFF specifications, checking the number of glyphs, the offsets, and some other info. For Type 1 fonts in PostScript format, again, there is nothing done yet. And whoever is able to read these PostScript fonts and check the outlines, for example, it will be really great to collaborate. For XMP, it's all done internally. ICC profiles, there is a tool coming from icc.org website, and again, running on all platforms. For digital signatures, the same. We don't go inside digital signatures apart from what's required on PDFA level. Checking, for example, there is only a single signer in inside the digital signature. For video attachments, we are lucky to have other parties inside PREFORMA project. In particular, Media Area provides a tool that does validation of video streams. So this is a high-level overview of what we are doing. Now I'm going to the area of how it is really implemented on low level. So as it was immediately indicated on very first meetings of the technical work group, we need to develop a certain validation model where we have objects and properties and validation profiles. And this is exactly what we've done. So we've got a certain hierarchy of object types, somewhat resembling PDF classes and PDF libraries. But that's all defined in our simplified syntax and can be implemented in any programming language. And then we have validation rules which are defined actually in the JavaScript Boolean expressions syntax. Well, of course, each rule has all necessary metadata saying where exactly it comes from, what is the description, what is the links to the error messages which are stored elsewhere. And rules are combined into validation profiles and signed. So this is a typical example of a syntax, how we describe our model. Again, that's a very simplified syntax. Even if it looks like a programming language, it is not. It is processed by a special component called xtext to convert it to really programming language. And this is a typical validation rule which are combined into validation profiles. That's an XML syntax, and here under test element you see a JavaScript expression. So size is less than 8192. That's actually JavaScript. Well, this LT is a standard XML encoding. Those who is not familiar with this, that's just less sign. So where we are now with this? First of all, we've finished the implementation of the validation model. So all the objects are defined. They are implemented in Java. And we've got the final version of all 8 validation profiles, 8 because we've got 3 parts, 3 conformance levels, but PDFIA-1 has only 2 of them, A and B. So you may ask how many rules, how many shell clauses you have in each of these validation profiles, and the answer is here. You have around 100 requirements on each of the levels and parts. Well, to be precise, 102 for PDFIA-1B, and I think 118 for PDFIA-3A, that's the maximum. And everything is open source, as I said. Here are the links on GitHub where you can find them. And actually, these two things, veraPDF model and veraPDF validation profiles, are really easy to read by still a technical person because we deal with XML files. But there is nothing against programming languages around. So it's something you can open and understand without any knowledge of Java or C++ or whatever your preferred programming language. And everything is documented in the wiki. Every rule, I mean everything. So every rule is documented on the wiki with exact citations, with notes from technical working group if there was some discussion on this. And the wiki is also freely available on GitHub. That's a standard GitHub wiki, actually. Well, I mentioned already that sometimes we get quite interesting discussions on technical work group. Well, a slightly bit more detail on this. So unused resources, what does it mean they are unused, not referenced for rendering? And the question is always whether such resources which are really not influence any appearance of PDF files, do they really need to be validated further on other requirements? Like a typical discussion was whether an unused image can use an LZW compression or not. And the answer was not, just in case you would like to know the result. and which version of ICC profiles is acceptable according to PDFIA-1 or PDFIA-2 and 3, what is implementation limits, of what is the length actually of a name or a string, in which whether you have to treat escaped or unescaped lengths or a name or string. These are typical questions going on. And how does it normally happen? As soon as we get a resolution, we update our validation rules, and here's a typical resolution that PDFE1 documents could accept IC profiles of internal version 2 and any internal major version 2 and any minor version. As a result, we ended up with a modification of validation rule. So I mention this because the process is very transparent. There is a discussion and there is a resolution, and this resolution appears in a quite easy to understand syntax, not in the programming language, not in the code or some internal code implementation, even if all code is also freely available. But we all understand that reading the code and reviewing the code requires completely different skills, and it's much easier to deal with like such XML requirements. So at the moment, I mentioned that we've got about 23 such ambiguities reported to the mailing list, and they're discussed during the regular monthly TWG calls. Formally, we are trying to come up to formal resolutions during the ISO committee meetings, where all technical experts are brought in the same room. Well, whenever we see that this thing might affect future development of PDFA standards, these ambiguities are forwarded to the PDFA project leaders. Well, how do you see this? If you want to understand how it's going on and what were the resolutions? Well, first of all, feel free to go and join the veraPDF mailing list where it's all distributed. The documentation on this is gradually included into the wiki, well, at a certain moment we'll have probably a special page devoted to this. So far it's just notes for relevant rules. Well, the model is good, but some code still needs to go inside and do real parsing work. At the moment, the parser is based on PDFBox. That's an open source Java library licensed under Apache. However, PREFORMA has a very, very strict licensing requirements, and I think we now understand where they come from. But I'm not going to go into this legal questions. So the requirement is that everything is delivered under dual licensing, GPLv3 and MPLv2. And Apache code is not, well, we cannot, it is compatible with these licenses, but cannot be converted to these licenses to be direct. So we are now doing a greenfield implementation of a parser. This means there will be yet another open source PDF parsing library soon available. Well, don't have any other choice. Development processes, it's all open source. On GitHub, Travis to manage continuous builds, Jenkins to manage integration at automated tests and deployments, and Sonar to monitor code quality. And all this, you go there, click and see the results. And actually, we start feeling the help of the community. We do get from time to time bug reports. Sometimes we get suggestions how to modify the code. Sometimes we get modifications which we just need to review and integrate in the code base. Typical examples where we've got an excellent patch that improved performance. We are caching of some objects while parsing the documents, and another company was doing integration and was not satisfied with our command line interface, so they suggested the improvements. So we do hope the community will grow and will get more and more contributions. But as I say, even now we start feeling this already. What we deliver in that? we deliver something that aims to be integrated into some workflows. And the interfaces we deliver are naturally command line, REST API. We had already on the talk on PDFR standard that REST API becomes more and more common nowadays. And this means we run a certain web server that supports this REST API, and of course a Java code. So whoever wants to integrate everything into Java applications, they can go and use directly Java API. Yeah, as mentioned already by Duff, we've got 2 other PREFORMA suppliers doing TIFF and video streams validations. And we have to come up with a uniform shell that detects the file type and passes this to right validators. So in the end, there will be not just PDF validation, but a uniform video, audio, and PDF validator. Today, we've got version 0.16 with the goal to finish by the end of this year, release 1.0. At the moment, it has the complete implementation of a PDFA parts and conformance levels, interfaces, cross-platform installer, GUI installer, validation rules, demo website, test corpus, and everything is freely available. So this is how it looks like. This is a GUI. That's a GUI of the tool. If you want, you can go install and see it on your desktops. All operating systems are supported. That's a command line interface, a demo website, very easy, demo veraPDF.org. Yeah, I probably don't have time to discuss other components, but there is also a metadata fixer that fixes some minor details. If the only thing missing to make the file correct is PDFA identification and the metadata, we'll add this. Yeah, that's probably the last slide. This is a timeline so the project started, the development phase started officially in April 2015. We've got now most of the implementation except for the Greenfield parser ready for tests, and we are hoping to spend half a year in very intensive testing of the software and improvements, performance improvements, optimization. Well, that will be the end of phase 2 by the end of this year, and as of 2017 there will be an official acceptance test done by European Commission. That will go till mid-2017. So that's an invitation to join the project. Now, of course, join PDF Association, join our technical working group, check what we've got so far, please share whatever test files you've got in your possession. Please send any test files you are not sure about whether they're valid or not. And of course, if you want, you can go inspect the source codes and even do modifications yourself, but please submit the codes as pull requests to GitHub. Or think how you can integrate the tool in your workflows. That's also important to us.
Thank you very much.